Hey, what's up, Ziguanas? This is day 22 of the 30 Days of Zig Coding Challenge. Join me one more time as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. I've had another crazy busy day, so I haven't had time to respond to comments, but I will do that. I will try to do that later today after the live stream. And yeah, so let's jump right into it. And today on the menu, we have vectors. By the way, for the ones that are watching this for the first time, I am learning Zig live. I haven't had any Zig experience 22 days ago yet. Today's day 22. And I had literally zero Zig experience. And the idea is that I document my learning process because I thought it would be interesting for others to see how someone who has a lot of experience with different programming languages, but not Zig. And also, it was, let's say, 15 years, not small experience of code teaching as well. So on the other side of coding, let's say like that. So I thought it would be interesting to someone to see how I apply the techniques that I learned from both sides to master a new language. And I was literally doing everything in front of cameras. So normally I wouldn't do that. I mean, not in front of cameras, but normally I would do much more repetitive things that are a bit boring for the camera. So that's why I'm handicapped a bit, because I am literally just using all these streams and nothing else in the last 22 days. So that will change in about 8 days. I will then start doing a lot of work on Zig outside of the stream, and then I will have, let's say, a more realistical conditions to practice Zig and to learn. But I was trying to show the general idea how I would approach, and how I think the practice is the most important thing. And that is the part that I'm actually missing the most now, because I don't want to practice the boring things in front of camera. So after 30 days challenge is finished, I will then practice a lot of things that are boring off stream, and then I will upload some more condensed videos where I will explain things. So this is not a tutorial, so I'm not trying to explain and to teach anyone Zig, because I don't know Zig yet, and I don't know even these basics. So the idea is that I just like learn live, and then after I learn these basic things and practice them, then I will create a tutorial where I will just like express the things that I learned from my point of view. Hi, Robert. Good evening. Hi, Dev. How are you? What's my job, by the way? I'm freelancer, so I haven't been employed since 2020, I think, as a permanent role anywhere. So I quit my job during the COVID. So everyone was scared during the COVID. They tried to keep their jobs, but I was like, I wanted to change. And I guess because everything started shutting down, and I wanted to do the opposite. I wanted to start traveling more, and I found that my previous job was limiting me, because I had 3 weeks per year of a vacation, and that's simply not enough if you want to explore the world, especially if you go to the other part of the world. So it costs a lot to just go to travel around the world, and then to go to the other part of the planet and then just to stay for 2 weeks. So it doesn't make sense financially and in any other way. So it's always easier if you have time to stay, let's say, longer, 5-6 months, and then you kind of compensate the price of the flights, which are the most, let's say, not maybe if not the most, but for sure one of the factors that are costing you the most. And then if you stay in the region, you can explore multiple countries, and then you pay low cost flights and you can travel by bus and so on locally. So that was the idea why I quit my job So that was the last time in 2020. Yeah, was the last time I worked as I was a full stack developer. Then after that, I started teaching first. So I quit coding for anyone else but me. I've done my personal projects and played just like for fun. I didn't want to publish anything or try to, I don't know, create an app that I will sell or anything like that. I was just like coding for fun. And then unexpectedly, I got some offers from my students. So some of them wanted me to do some projects for them, to code projects for them. So many different things. So I had clients because I also traded Forex before. So I also coded bots in Forex to trade Forex. So I had clients that wanted to do that. I had clients that are interested in blockchain, and I was literally like practicing blockchain and doing some personal projects for a while, let's say in 2020, 21, maybe maybe a bit longer before I got the first blockchain client. And that's basically what I do. So I don't search for the job, only someone who I already know, like my students, or if someone comes by the recommendation, I accept the projects that are interesting to me. So this is basically what I do. So I lived entirely 2020, 21, 22, I think as well. Most of the money that I earned was from tutoring, mentoring, and things like that. So not coding. I did code, but that was like a minority of my income came from that part. And then again, I started coding more in the last maybe 2 years. I don't know exactly. So I started doing this, but only things like this. So I never tried to. I actually tried during the COVID. I wanted to move to Canada, so I tried to. I started the process. I was having some interviews with some Canadian companies, and then because of COVID, everything stopped. So I did because I have a master's, not master's, sorry, bachelor's of applied electrical engineering and computer science. Sorry, not computer science, electrical and computer engineering in Serbia. So I had to, how you say, in Serbian we say something like, if I were to translate it literally to English, it would be something like nostrificate, something like that. So basically to validate your diploma abroad, because it's not the same, the systems are not the same. So then I sent my diploma, not me, but my university sent my diploma to some Canadian company. WES is the name. So these guys who confirm, and they confirm that your diploma wherever you are in the world is equivalent to some diploma in Canada. So I did all these things. So I took the paper, like the documentation from the police that I'm not convicted or anything like that, that I didn't have any problems with the law. And then I also passed IELTS language, and I was literally like almost bought the ticket to go to Canada, and then COVID started and they closed the country. Then I kind of like quit the idea to move to Canada because I already started earning. So I maybe I cannot say this the more than in Canada I would, but the cost of living is much cheaper here in Serbia and everywhere I traveled. So for example, I was in March and April, right? So first the last half of March and the first half of April, I spent 1 month in Brazil. So I was 5 months in South America, but 1 month and a half I was in Brazil. And of that 1 month in Brazil, I spent in one city called João Pessoa, and I paid $300 for a month. So to stay there. So I mean to rent the on Booking.com, so only like the place to stay, not the food and everything. But that's so much cheaper, and it simply doesn't worth. If you move to Canada, I think in Vancouver, where all the companies are, you have to pay like $2,000 or something like that for something that is, let's say, relatively close to the company. So that's the reason. So I kind of like, I don't care anymore. I don't want to do it anymore. And they also closed the country, so it's more difficult now. So I don't want to bother. How's the tech scene in Serbia? So yeah, basically it's the same thing. I think because I haven't tried to find a job for years. I don't know for sure, but speaking with my ex-colleagues, I see that they struggle a bit more than before. So I think there are less jobs, less job listings currently, and I think this is basically because they during the COVID and these like 2020, 2021, 22 maybe, they started to overemploy people. I think it's not the AI or anything like that, but simply they started to employ more than they need, and then finally, and everyone was sitting at home these like few years, and everything was digital, so people bought digital products more than nowadays, and now everyone is more outside, let's say again. So I think this is also one of the reasons why, and I think it's more or less the same in the world. So in Serbia is the same. So I have, for example, I have a friend who is a developer, and he is changing jobs still, like I don't know, maybe once per year. So he now works for two companies here in Serbia. So I mean, they're not technically they're not Serbian companies, but he lives in Serbia and works for them. So one of them is actually, I think, a Serbian company. So yeah, I think it's more or less like anywhere in the world currently. But it's easier, it's a bit cheaper to live here in Serbia, but it's not that cheap. So like what I said for Brazil and Latin America in general, it's much cheaper to live so than in Serbia. In Serbia, you have the cost of living is not that high like in the United States and Canada, for example, but the salaries are lower, also much lower than compared like with the cost of living and everything. So it's not like not like that. Let's say, for example, if you had, I don't know, 2 times 3 times higher salaries in United States, and that you have 2 times 3 times higher the cost of living. So the cost of living is not that different like the salary. So that's the reason why it's not so easy in Serbia to do. I mean, it's not like that it's the worst job here. So developers are among the highest paid, but just like compared to the world, like what I said. So I prefer going to Latin America where you have much cheaper whatever. So like whatever you want to rent, and if the food and everything, it's very cheap compared to Europe, anywhere in Europe. Okie dokie. So let's do some vectors. Let's see, I read this yesterday, this part, so I'm not going to read all these details, especially for SIMD here, but let's just quickly go through the first maybe 2 paragraphs and these operators, and then I will jump into the code. So a vector is a group of booleans, integers, floats, or pointers, which are operated on in parallel using C. Okay, like we are not going to see. Yeah, we have to mention obviously. So using SIMD instructions if possible. Vector types are created with the built-in function, this one that we touched yesterday. Vectors support the same built-in operators as their underlying base types. Yeah, so they're just like wrapping them right in this way. These operations are performed element-wise and return a vector of the same length as the input vectors. This includes arithmetic, bitwise, and comparison operators. So perform element-wise and return a vector of the same length. That's important. And then, yes, I will just read this because this is also important. So it's prohibited to use math operator on a mixture of scalars and vectors. So you cannot mix them, which makes sense. Zig provides the splat built-in to easily convert from scalars to vectors, and the other way around, reduce, which will take the array and convert it to a scalar. Okay. For rearranging elements within and between vectors, Zig provides shuffle and select. Okay, so let's see a bit of the code. Okay, here, and let me see if I can zoom in safely. So yeah. So the first thing they do, they create a constant. They call it A, called the built-in function. Then they say it's the vector of I32s, I guess, 4 elements. And then they have this 1, 2, 3, 4 inside of them. And then they do see the similar thing for B, just the elements are different. Let's see what they say. Vectors have a compile time known length and base type. So it's always compile time known length and base type. Both of them are compile time known. Okay. Operations take place element-wise. On C equals A plus B. This is so cool that you have this on the level of the language. I know, for example, in Python, if you want to do something like this, let's say with lists, first of all, they're slow. But if you just ignore that they're slow, there is no operator that will do this in Python on the regular list. So you have to use NumPy arrays, for example, or pandas and their series or data frames, and then you can do things like this. So they built entire library, actually several libraries, to do this in Python. And you can do it just like that in Zig, which is a bit weird because someone would expect that Python has things like this. Maybe not from the beginning, but because it's so popular and it's used so much with the data science, then someone would expect that you have something like this built in the language. Maybe they'll do it in some future version, who knows. But this is so cool. So literally you can do data science with this by default. Use the default built-in types. Individual vector elements can be accessed. So this is some details, maybe like for someone it's not so important, but for me this is very, I don't know how to express how I feel about this, but it's so cool that you can do this element-wise operations. And I guess you can do all of them the regular ones. Let's see the next thing. Individual vector elements can be accessed using array indexing syntax. Okay, so that's expected. Then they say, okay, they just test a few values. So they take first the C, which is A plus B. So it will be 6, 8, 10, 12, right? So then it takes the first one and expects to be 6. So yeah, 5 and 1 are 6. Then 8, 10, 12. Yeah, so respectively 8, 10, 12. Okay, conversion between vectors, arrays, and slices. Vectors are fixed length arrays and, vectors and fixed length arrays can be automatically assigned back and forth. So they create one constant, call it ARR1, which is array of F32s, right? 4 elements inside. Then they do this, they have this literal. So they provide these 4 values for float literals, comp time floats, right? And then, of course, this is the same type. And this is compile time known size. And then they create a vector. They use the built-in vector function to say that they want to take this array and then assign it to vectors. So they are conversing it. How do you say? So converting, yeah, sorry, from array to a vector. Sorry, I'm about to sneeze again. Sometimes it's so annoying. It happens all the time in life. Not all the time, but always. Let me see what you wrote, Robert. Also, not to forget, it's all, yeah, SIMD. So, yeah. I think it's literally a matter of time once until someone will write some game engine in Zig that will probably become very popular. So maybe they are all already doing something like that. I'm not in those waters. I've never worked as a game dev. I like to do things like that personally, but since the beginning, I heard that they are not paid well and that they are like exploited. So that especially when there are deadlines, if there is, let's say, they won't have to publish the game or a patch or whatever, and let's say in the next 2 weeks, then they stay and work like 60 hours per week or more, and they are not paid enough. Very stressful. Let's see the next thing, const arr2. So they take this vector and they it back to array, convert it back, okay? And then they expect that these are equal, and they are, because all the tests passed, okay? Then the next thing, you can also assign from a slice with comp time known, comp time known length, to a vector using dot star notation. And then they give example. So const vec2, they have a slice with comp time known length, which is in this case stated here. So from 1 to 3, that's 2, right? The length is 2. And then they use this to assign from slice. So they the reference, right? The slice, and they take it into vector. So I guess this is because slices are pointer and the length, and because vectors have to be, how they said the exact word, they have to be, if not defined, how they say in comp time. What was the word that they used? Where it was? This one. So vectors also support assignment to and from fixed length arrays with comp time no length. So you can play with these things only if it's known by in the comp time. That's what I wanted to say. But I forgot how they phrased it. So that's how. So they take the slice, reference it, and then make a vector that has 2 elements of F32 type. Okay, let me see what you got. Hi, Jorge, how are you? Let me see what you wrote. Several people are trying to make game engines in Zig. Yeah, I believe, I mean, these things are amazing. It would be crazy if nobody's working on this. There are also lots of ports bindings for C libraries like Raylib, for example. Nice, cool. Yeah, I can see the bright future for Zig for game devs. On slice. Okay, so they create a constant slice of F32s, and they take the array1 from here, and they take the address of the array1. So this array here, they take the address, make it a slice. Okay, then what's the next thing they want to do? Offset. It's a variable, and then they just dump it here, so they are not going to use it. Then they say the type is U32, and they use the literal 1, assign it, make it runtime known. Okay. So they wanted to explicitly play with runtime here. That's why they used var. Then suppress, okay, never mutated, okay, never mutated. To extract a comp time known length from a runtime known offset, first extract a new slice. Okay, this is so important to memorize, and I have a feeling that I'm going to forget So let me try to pay attention as much as I can. So to extract a comp time known length from a runtime known offset, like in this case, runtime, first extract a new slice from the starting offset, then an array of comp time known length. So let's see how they do it. They create constant vec3. They use the built-in vector, say it's 2 elements inside of f32s. Then what they do, they take the slice, right? So this is the slice of this one in this case. They take the offset, which is this runtime known variable. They start from the offset until the end. So once they have this slice, then they take this one. They do this one. So they slice again, double slice, but in this time they take the entire thing. That's not the entire thing. Here they took the entire thing, and here they took only the first 2 elements, and that's why here they say 2 and not 4, like at the beginning. And also they are not taking the first 2, but because of the offset, right, 1, so they are taking these 2. And then and let me read one more time. So first extracts a new slice from the starting offset, then array of comp time known length. Okay. So this is basically then making it array. Yeah, so like what they did here. Yeah, it's the same. So they make here the comp time known length array. So this is the regular slice, and then this is the part that will make it known at comp time, if I'm not mistaken. And then let's see what they try to compare. Slice offset. So they take the first, not the first, but the one with index 1. So the second element of the slice. So this one, right? And they take the first element of the vector 2, which is the slice. It starts from, so the array, not a slice, sorry. I mean, it's vector, but it started from array. That's what I want to say. And this one starts from the element with index 1, so from this one. So because it's the first one here, then it's the same. So they are comparing 3.2 with 3.2. So I get, yeah, they passed the test. Then the second one, okay, this is just like the offset plus 1. So they are comparing 4.5 and 4.5 here and here. And then finally, vector 2 and vector 3, this one. So vector 2 is taking these 2 elements, and vector 3 is taking, again, because it starts from offset, it takes first all these, but then it takes here these 2. So they are the same. Okay. Okay. Let me see what Robert wrote. Vectors are one of the last things that are currently missing in the incremental compiler Zig team is working on. They are not easy to do properly. Thanks for the update. So then I guess they are going to include them as soon as they can. Destructuring vectors. So let me first see what they say. Okay, to do. Consider suggesting STD multi-array list. So then they mention split and reduce. So to convert to the scalars to vectors, vectors to scalars, and these two that are shuffled, that shuffling them, and select. Okay, so then destructuring vectors. Vectors can be destructured. let's see, they have two functions. This one is main, the regular one, and this one is the custom unpack. So they take two parameters, and both time they will call a built-in to make a vector out of the input. Okay, then they also return the same type. Then let's see what they do. They create a const A, const C, and two of these things just to dump. And they set it to X. So they take the four values, they dump the two, and they just store the first two. And in a similar way, they do here for the Y vector. So they take only the first two elements, dump the second two, the last two, and they just store this in two constants, const B and B and D. I was about to say C. And then they return. So this is a tuple, right, with A, B, C, D. And then they are converting that tuple to a vector. And let's see what they are doing. So they create a constant X. They say all this built-in with these in a tuple. Similar thing here, but just different values. And then they call the unpack here for the X and Y. And then they will return A, B, C, D. So A, B, C, D. So first from X, first from Y, second from X, second from Y. And that's what they are going to print. And that's why the first from X, the first from Y, sorry, the second from X, and yeah, the second from Y, and they just using the scientific. I mean, the output is in scientific notation by default. Okay, then let's see what they suggest to take a look. Destructuring tuples, so general structuring, then destructuring tuples and arrays. Pointers I've done. So I would just like to have a quick look here. Split, reduce, shuffle, select, just for higher overview. So any type, input output produces a vector where each element is the value scalar, the return type, and thus the length of the vector is inferred. So they have this scalar, they call it scalar of type U32, assign 5 to it, and then the result is a vector of 4 elements, 4 U32s, and they are calling this split built-in, and then they try to expect blah blah equals if they are U32 type and address of as. So here they convert the result to array of U32s with 4 elements, take the address of it, and they compare if that's the same thing like here this anonymous array, which has 5555 as elements, again U32 the same type, and because they pass the test, it means they are equal, which proves what they said here, so that it takes the scalar and repeats it this many times. That's how they work. Okay, nice to know. So I haven't thought about it. When they said that they are converting scalar to a vector, I didn't give it a thought at all how they do it. And if they are repeating or they are setting the other elements to 0. But here is the answer. They just repeat the same scalar with the split. Probably this means something like that in English. I'm not familiar with this split word in English, what it means. Probably if I understood the meaning of it, I would maybe have guessed that this is going to happen simply from the name. And here, the next thing, reduce, is the opposite. So let's see, the inputs are two of them. The first one is this type, under built-in reduce OP. They just call it OP. And here they have another one, value, any type, and they have this E as the type of return, so generic, transforms a vector into scalar value of type E. I wonder why they choose here E. Usually it's T, unless it's an error. But let's see why, if they maybe explain. Transforms, I mean, you can use anything, but I'm just curious. Transforms a vector into scalar type of type E by performing a sequential horizontal reduction of its elements using the specified operator. Yeah, because you can reduce it in many different ways. I know this from functional programming, how it works, that you provide like the rules, how you're going to have a larger set into smaller. In this case, it's in one, but you can do reduce. I forgot if you can do it in, yeah, I think you can also have output, not only one. Maybe I'm mistaken. But in this case, for sure, it's one. So not every operator is available for every vector element type. Every operator is available for integer vectors, and or XOR are additionally available for bool. Aha, this is like every operator is available for integer vectors. And then these are additionally available for, okay. And then these four, minimum, maximum, addition and multiplication, additionally available for floating point vectors. Note that add and multiply reductions on integral types are wrapping. When applied on floating point types, the operation associativity is preserved, unless the float mode is set to optimized. Yes, so many details, but it's cool that you have this control that you can do it in depending on the use case. Let's see what they do with the reduce. So they create this constant v vector. They say it's going to be 4 elements inside of i32 type. Then they create a value, which is again v, so this type. So 4 elements i32s with these values. Then they say they want one more const, and then they say, let's see, from inside out. So first they convert or coerce the 0, so they split it into a vector, so they create a vector of 4 zeros, and then they say result is equal to value greater than this one. So because it's Boolean operator, then it will be true, false, true, false. So they create these, yeah, they literally say it here. Then they try comp time, okay. They want to see if type of the result is equal to vector of 4 bools. So yeah, that makes sense because we know this is going to happen. So then this is equal. Then they have another constant is all true. They want to take this result and use the reduce built in. And this is the operation. So they are going to end it, so the Boolean end. And the result is the input. This is the output will be, so they will do in the series, right? How you see all the elements one by one, compare them to each other, and then they are going to have, so this is basically, so here we have this output, so true and false, and then the result and true, and then the result and false, if I'm not mistaken. And then this is going to be because you don't have all truths and you're doing AND, you're going to get false, so this is then going to be true that it's false. And what they also here compared, if the type of is all true equals bool. Yeah, it is because it's false. Okay, this one is clear. Let's do the next one, shuffle. Okay, this one has a bit larger signature. So 1, 2, 3, 4 inputs, and the output is a vector which takes this type E and whatever is the mask length. So it will be that many elements of this type in a vector, and E is here, here, here. So all these first 3 inputs are of the same type, like here in the output. And of course, the mask is a mask, so it's I32s with this size mask length, so the same size like here. Then let's see what is the first element. Is type A. It's 3 elements, sorry. So because it's so, no, it's 4, yeah. So A, B, and type is the first one. Yeah, of course. Okay. So first they have this comp time type, generic type. Then they have the A and B, which are both vectors, and they have different lengths. So A has some length of A, and B has a different length. But the mask is important here because it has to match the output length has to match this one here. Okay, so they don't have to be the same size. Then let's see what they say. Constructs a new vector by selecting elements for A and B based on mask. Each element, so I'm just curious to see how they are going to, what they're going to do if they're not the same size. Each element is in mask selects an element from either A or B. Positive numbers select from A starting at 0. Okay. Negative values select from B starting at -1 and going down. Makes sense. It is recommended to use the not operator for indices. So I think this is binary not, if I'm not mistaken. Operator for indices from B, for indices from B, so that both indices can start from 0. Okay. So the example is they convert 0 as, so yeah, because it's comp time int, so they convert it to I32 and then they negate it. And they will get this, right? Because it's the, wait, this should be, yeah, it's bitwise negation. Yeah, okay, it's not second complement, it's the negation itself. Okay. For each element of mask, if it or the selected value from A or B is undefined, that was my curiosity. Then the resulting element is undefined. A len and B len may differ in length. Out of bounds element indices in mask result in compile errors. If A or B is undefined, it is equivalent to a vector of all undefined with the same length as the other vector. If both vectors are undefined, shuffle returns a vector with all elements undefined. Okay. It must be an integer, float pointer, or bool. So numerical types. Okay, I mean bool also. Not numerical, but kind of like 1 and 0. The mask may be any vector length, and its length determines the result length. Okay. Yeah, that's what we saw here at the beginning. And let's see the example. So they make 1A vector, which is 7 elements of U8 type. So this is what they have, some random characters, and then they have 4 characters for B as a vector. Then they say to shuffle within a single vector, pass undefined as the second argument. Notice that we can reorder, duplicate, or omit elements of the input vector. So let's see the example. Mask1 equals vector 5 characters in the vector, 2, 3, 1, 1, 0. Okay. So then they have the result, which is also a vector of 5 elements, but this time U8 is the type, not I32. And then they set it to whatever comes out of shuffle. And they do say in shuffle that the type is U8, so the generic type here becomes U8. Then A and B are AB vectors with different lengths. Sorry, here I jumped. Then, no, in this example, B is defined. In this one, it's not. So they say A is this one, and they set B to be undefined. And then they use mask1. So this one here with 5 elements, and B has 4. Oh, yes, yeah, actually, we don't care about B because they take only A. So then let's see what they try to see. It's equal if it's hello. And then this is interesting because they mask it and then they make out of these characters, they will make this. So they take the result 1 as the input to the as built-in function, and they convert it to the array of U8s with size 5, and it used to be 7 size, right? And it was vector, so they convert it here to an array, and they take the address of it, and then they take the hello literal. Okay, one question, guys. So in many programming languages, you will have, if you have strings, you will have string pool. So if you have, let's say I create 1 times hello, assign it to something, then I do it the same the second time. So they will not actually use 2 times the memory. They will use the same string once in memory. You will just have 2 names for it, 2 references, if you will, or variable names, however you want to call them. So is this the same thing, and is that the reason why they are using the address of operator? Or there is another thing that I'm missing here? Robert says, yes, Zig has it too. Okay, okay. And is this why they have the ampersand here, the address of operator, or there is something that I'm missing? And let's see. Actually works for most comp time values. What I wanted to do. Okay, they compare. So obviously it passes the test, so it has to be the same. In this case, they are taking the result, convert it, so the result is a vector of 5, which they take from the shuffle, which receives 7 elements long vector and undefined B, and mask 1, which is 5 elements. So we have 7 elements here, undefined B, and mask is 5, and it will then return only the first 5, I believe, characters of this A. And then what it does, I will just do 1 character just for fun and to double check. So we have O as the character. So I will need the O Unicode number. I can actually print it as a character, so I don't even have to take a look in the Unicode table. I can just print it. So then I will get some number, and I want a binary version of it. And then the mask here is 2. And it starts as I32, but then it doesn't matter because the leading zeros are the same. So this is small enough that it can fit even U8 or smaller. So 2 would be 1 0 at the end, and leading zero, oops, sorry, and leading zeros here. And then I have to see what is the number for O in binary. And then when they shuffle it with this mask, they receive H at the first one. So this would be interesting to see how it looks in the real world, and just to see. So they have the mask, and what are they providing as the operator for the mask? Which operation? I missed that part. So they have the type, the vector, A and B, the mask, and they shuffle. So this is how they explain the mask. Each element in mask selects an element, either A or B. Positive numbers select from A, starting in 0, negative values. Yeah, so this is how this is the logic. So because it's positive, it will take from A. Negative. So I guess 1 takes it, 0 will mask it. It's kind of like the end, I guess. So we can play with this. Let me just see here. So Unicode, yeah, UTF-8. Let's see this one, and I'll just quickly find, because I'm too lazy to print C, and it's not here. Unicode, let's say characters, this one, and we want O and C just to compare them, lowercase O and C. So O is here, it's 111. Are these decimal? Decimal, yeah. So 111 is O. So this one is 111, and H is 104. 104. And we have to convert it to binary. Actually, we should have here the binary, or at least hex. So this is hex, right? The column. Yeah, this is hex. This code, this is hex. So where it was? Oh, here, so 6F. So this should be 6 is like this, I believe, 110 at the end. And F is all ones. So like this, if I'm not mistaken, 6F. And the H, where is the H? 6-8. So 6 again like this, and 8, I believe it's like this. So this is the output, right? The H is the output. This is the O, the input. And let's see what they did. And the mask was, I think, 2, right? 1, 1. Give me just a second to see where it was. Here, the mask. Where are you? Here, 2 was for the first. So yes, 1, 0, not 1, 1. 1, 0 was the mask. So mask was 1, 0. So this, if it takes 1, filters out here because 0, I understand why 0. This one, then I understand why this is. Aha, the zeros are, okay, the zeros are taken. So this will pass, this because it's 0. This, yeah, it's not like that. So yeah, it's probably here I'm missing it. I would have to read this more carefully, but that doesn't matter. So I don't want to spend a lot of time. I just wanted to quickly see. Not going to waste more time. Let me see what you guys said. Jorge says 2 is an index of A. They are not. Aha. Okay, it's an index. Okay. Thanks for explanation. It makes sense. Okay. So they take this first. So they take the indices and they apply the mask in that way, and that's why the shuffle will get you hello. So index 2, right? Like Jorge said, then 3, then 1, then 1, then 0. Hello. Yeah. Okay, perfect. Thank you, Jorge. Then the next one, they use B. In this case, not undefined, but they have B. So this one here. And then the mask is also different. So they have 1, 2, 3, 4, 6 elements in. Yeah, it says here. Then they have the result 2, which is taking. So A is still like before there. B is now used instead of undefined, and they use a different mask. And they take this as a vector of 6 elements of U8s. And let's see how this works. So they said if it's minus, it takes from B, if I'm not mistaken. So then this is from the B, minus 1. So this one comes from the B. Then this one is from the A. Yes, it is the 0 index. Then this one is positive. So again, A, 0, 1, 2, 3, 4. Yeah, world. So R is coming from there. Then 1 is positive. So 0, 1, L here. Okay. Then minus 2, it's B. So the second in B, right? So D. Yeah, okay. Then minus 3 again, the third in B. This one, yeah, okay. It's clear now. Perfect. Let me see what you guys wrote. Jorge says that's what 22 days of Zig does to your mind goes to beat witchcraft. Yeah, it's a conspiracy. I have to decipher this. Who knows what they did? Literally, yeah. Okay, so this was the shuffle, and then the last one is select. Let's see. Okay, they don't actually dig deep into it. They just show the signature and just like a brief description. So let's see. The same like with shuffle. So comp time type. Then they have a vector that is a boolean of some length. Then they have a vector and a vector, so a, b like before, and they are this time they are the same length, so they are all the same length. So this but probably predicate or something similar, so they all have the same length including the output, and they are the same type, a, b, and output of this type, generic type. And of course this is different, this is boolean. Selects values element wise from a or b based on predicate, I guess. If predicate I, so if the index of that one is true, it's going to be from the A, otherwise B. Okay, so similar to before, there was just like in shuffle, if it's positive or negative, it's positive then from A, if it's negative then from B, and here it's true from A, false from B. I would love to see some example, but I can also play in the future with these. These vectors seem very cool. Okay, so then let's see where I stopped here with the vectors, destructuring vectors. We've done this. Yeah, so we basically finished with vectors this time. Let me see the time. So I'm like 1 hour already in the stream. So I can do just quickly what I mentioned before yesterday. Let's read this Zen. So something just to relax my brain for a change. Let's see something that is completely different. So the Zen of Zig. Communicate intent precisely. Edge cases matter. Favor reading code or writing code. Oh yeah, I've been doing a lot of reading code the last 22 days. Only one obvious way to do things. Runtime crashes are better than bugs. That's true. I mean, these are all true. Compilers are better than runtime crashes. Yeah, this like this. Hierarchy. I incrementally improvements. Avoid local maximums. Reduce the amount one must remember. What? Reduce the amount one must remember. Ah, okay. Got it. So reduce how much one must remember. Okay. Focus on code rather than style. Resource allocation may fail. Resource allocation must succeed. Yeah, that's important. Otherwise, memory leaking. Memory is a resource. Together we serve the users. Nice. So then this thing here is kind of like preventing me from seeing the language recommendations, how you should do the four spaces and things like that. So because they say focus on code rather than style. So I cannot now. I cannot disobey the Zen. What do I do now? Let's just take a look quickly. So where it was somewhere here. Style guide. Yeah, here. Let me see what Andre says. Sorry, first Robert. By the way, guys, I have mentioned it in yesterday's streams, but since we're done with Zigzag I have made an issue on GitHub with showcase of what its implementation could look like. Great, perfect. I haven't had a chance to see it. I didn't get any notification, so I will see why. But definitely I will look into it. Let's see what Andre says. Avoid local maximum and incremental improvements seem a bit contradictory. Yeah, this is like the abstraction and philosophy. Let's see what Robert said later. Feel free to check it out or improve. Goal was not the most optimal code, but showcase what language features we can use there. Yeah, that's the point, that we can play with it, not for making it perfect, but to explore and what can be done and the flavors of Zig. Okay, let me see what they say about the style guide. These coding conventions are not enforced by the compiler, but they are shipped in this documentation along with the compiler in order to provide a point of reference should anyone wish to point to an authority on agreed upon Zig coding style. Avoid redundancy in names. Avoid these words in type names, value, data, context manager, utilsmiths, or somebody's initials. Okay. Everything is a value. All types are data. Yeah, that's true. Everything is a context. All logic manages state. Nothing is communicated by using a word that applies to all types. Temptations to use utilities, miscellaneous, or somebody's initials is a failure to categorize, or more commonly, over categorization. Such declarations have again, I'm imagining words, can live at the root of a module that needs them with no namespace needed. Okay, avoid redundant names in fully qualified namespaces. Every declaration is assigned a fully qualified namespace by the compiler, creating a tree structure. Those names based on the fully qualified namespace, and avoid redundant names segments. Choose those I cannot read. Choose names based on the fully qualified namespace and avoid redundant name segments. Okay, let's see what they do as an example. Const JSON struct, const JSON value is union enum number. Okay, boolean JSON value. Yeah, redundant. In this example, JSON is repeated in the fully qualified namespace. The solution is to delete JSON from JSON value. In this example, we have an empty struct named JSON, but remember that files also act as part of the fully qualified namespace. This example is an exception to the rule specified in avoid redundancy in names. The meaning of the type has been reduced to its core. It is a JSON value. The name cannot be any more specific without being incorrect. White spaces, four space indentation, open braces on same line unless you need to wrap. If a list of things is longer than 2, put each item on its own line and exercise the ability to put an extra comma at the end. Okay, line length, aim for 100. Use common sense. Names, roughly speaking, camel case function name, title case type name, snake case variable name. More precisely, if X is a type, then should be title case, unless it is a struct with 0 fields and is never meant to be instantiated, in which case it is considered to be a namespace and uses snake case. So these are basically exemptions, right? If X is callable and X return type is type, then X should be title case. If X is otherwise callable, then X should be camel case. Otherwise, X should be snake case. Acronyms, initialisms, proper nouns, or any other word that has capitalization rules in written English are subject to naming conventions, just like any other word. Even acronyms that are only 2 letters long are subject to these conventions. File names fall into 2 categories, types and namespaces. If the file implicitly a struct has top-level fields, it should be named like any other struct with fields using title case. Otherwise, it should use snake case. Directory names should be snake case. These are general rules of thumb. If it makes sense to do something different, do what makes sense. For example, if there is an established convention, such as innuent, follow the established convention. Then examples. So namespace name, type name, global variable, const name, primitive type, alias. Okay, these type aliases, I haven't seen them here in the docs, but it's cool to know that they exist as well. String aliases, okay. Struct name, struct field, struct alias, function name, because it returns void in this case, param name, type name, var function pointer, function name. Then here, of course, they use the same thing, function pointer, other function. Const function alias, function name, okay. This is a different kind of function. So list template function, because it returns type, right? So that's why. Comp time child type, comp time fixed size, usize, then it returns the list. Okay. Child type fixed, okay. Short list, comp time t, comp time n. So this is the type. That's why. And type here, lowercase. I mean, this is there, not our. Return struct field name. Okay. Method name void. Okay. The word XML loses its casing when used in Zig identifiers. Okay. Then XML parser, because it's a struct, they have X here. Then the initials big endian are just another word in Zig. So that's why it starts with B and then lowercase e. Okay. Nice, nice. So I will stop here. Let me see what I will do tomorrow. Let's see, now it's a bit jumpy. So this tool requires me to install Zig locally, which I still haven't done. Illegal behavior. Let's see. Yeah, this is a huge one. Illegal behavior, then memory, file variables. Okay, compilation model. This is interesting. Maybe I'll start with this tomorrow. Big build system again will postpone. Okay, this is related to compile, so maybe I will do tomorrow. I'll just, so I guess it's going to be more theoretical tomorrow. So I will try to see these compilation chapters, including targets. So yeah, I think I will do that. Then definitely I will have to install Zig finally before I continue, because I'm running out of things I can do without installing it. And let me just double check the memory, what they say about the memory. Aha, okay, this is also interesting. So maybe I will do this tomorrow. I will see where I will start from, either memory, or maybe I will be able to do both of them. So let's see. So that's the plan for tomorrow, either memory or these compilation related things like targets, because like targets of compilation, and these two things, and then maybe a memory before. That's the plan for tomorrow. Okay. Thank you guys one more time for being here. I had so much fun in these 22 days, especially in the last ones. So as the time passes, I'm having more and more fun, and it's going to be even more interesting once I finish this 30-day challenge, because I will do more practical things and I will practice more. And then I will code more, not read that much. I mean, I will still have to read, of course, to understand things, but I will try to code more as much as possible. Which OS am I using? Here I'm on Windows on this machine. So I do have another one here, which is Linux. But generally, this is like my main computer that I use. So yeah, I think this is the plan for tomorrow and for foreseeable future. Thank you guys for being here, and see you tomorrow. Yeah, about in the same time, actually a bit earlier. I think so. Today I had something to do. That's why I was a bit late again, but tomorrow definitely I will should be available a bit earlier. Thank you guys, and have a nice evening or day, depending where you are, and see you tomorrow. Bye bye.